Okay, here we're going to look at evaluating logs. Okay, so say you want to find log base 2 of 4. What you're looking at then is 2 to the what equals 4. So off to the side you can go, well, 2 to the x equals 4. X must be 2. Okay, so that's going to be 2. Okay, because you're looking at the inverse. Okay, now if you want log base 3 of 27, well, then you'd go 3 to the what equals 27. Well, 3 to the 2 equals 9, times 3 again is 27, so it must be 3 to the 3. So you'd say that's 3. Okay. Now you could have other ones here. So log base 2 of 1/4. Okay, so now you're taking logs of fractions, which you can do. You can't take the log of a negative. If we think of the graph, there is nothing on the negative side. Okay, so this one here, well, 1/4 to the what? Okay, sorry, 2 to the what equals 1/4. 2 to the what equals 1/4. Well, that's going to be a negative exponent. Okay, so you can't take the log of negatives, but you can get the negative when you take the log of a number. Okay, so just by looking at the graph here, so here's a log. Log of numbers that are between 0 and 1 are going to give you negative values, but you can't take the log of a negative x. You can get a negative y, but you can't take the log of a negative x. Okay, so log of 1/4 is going to be negative. Now, 2 to the what equals 1/4? Well, 2 to the negative 2. How could you look at that? You could say, okay, so 1/4 is 4 to the negative 1, if we use our exponent laws, and 4 equals 2 to the 2 to the negative 1, which then equals 2 to the negative 2. So 2 to the negative 2 equals 1/4. So that would be, the answer to that would be negative 2. Okay? Now, a nicer way of writing these would be like this. So if I take this one, I go log base 2 of 4 equals log base 2 of 2 to the 2. These are inverse functions. Log base 2 and 2 to the x are inverse functions, so that's just the answer. These kind of cancel each other out, like square rooting cancels out squaring. Okay, so that ends up being 2. You'd also be able to say if log base 2 of 8, well, that equals log base 2, 8 is 2 to the 3. So 2 to the 3, these cancel each other out, and you just end up with a 3. Okay, if I want to write this one nicer, log base 2 of 1/4 equals log base 2 of 4 to the negative 1, which equals log base 2 of 2 to the 2 to the negative 1. So we try to get them so that they're same bases so they can cancel out. That equals log base 2 of 2 to the negative 2. And these cancel out, and it just gives you negative 2. Okay, so that's one way of looking at that. Now, what if you want to take log base 5 of cube root of 5? Okay, well, you're just going to change this to an exponent. So log base 5 of 5 to the 1/3. Okay, they're inverse functions of each other, and that's just going to give me 1/3. All right. What's another one here? What if I did 2 to the log base 2 of 7. Again, these are inverse functions of each other, so those cancel out, and it just gives you 7. Okay, there's not really much to do there. And one more example, you could do log base 3 of 7. Okay, you can't do this on your calculator. But basically, what you want is that to equal log base 3 of 3 to the something. Okay, so 3 to the something equals 7. Well, 3 to the 1 equals 3, and 3 to the 2 equals 9. So what you do here is you take your calculator out and just keep trying numbers until you get close, and depending on how close you want it, then you can predict what log base 3 of 7 is. Okay, so you might not get it exact, but based on your knowledge of logs now, you can approximate this pretty good by using your calculator. Okay, and we're going to end it at that.